Hi, everybody. I'm Lance Delano. I am from the Power BI Desktop team. And this session is about data modeling with Power BI Desktop. This is intended as a education kind of thing. We're not going to talk about the latest features, although we'll touch a little bit on that, in data modeling per se. But we will be talking about the kinds of things you want, the practices you want to follow to get to a good data model. The first question you might ask is, what do we mean when we talk about a data model? It means it's clear in some people's minds, but not so clear in others. So when we talk about data model, there's things that the query kind of brings into the model, and they include tables and columns, and you do a bunch of transforms, and you land in the model with some tables and columns, and you have, at the top end, you have things like calculated columns or calculated tables. And I would actually argue that anything that adds to the structural nature of the thing that your reports are going to be built on is part of what we're going to talk about today. So that includes, obviously, tables and columns and data types and categories and relationships and hierarchies, but also calculated tables and calculated columns. You get this right, and everything else goes a lot better later on. We're also going to talk about a couple of the common problems that people run into with data modeling, notably multiple fact tables, many-to-many, and date tables. So those are the kind of things we're going to hit. And as we go through, we'll kind of do some guidelines, and we'll kind of weave through these topics. All right, so we're going to start with data types and data categorization. And the important thing to understand, I'm not going to go demo this part of the product because it's pretty straightforward, but there are some nuances here you should be aware of. So when you build your data model, the first thing you want to know, first piece of advice, rule number one, check your data types. If we bring the data in from something like SQL Server or something else where there's a relational schema and it's got a data type, we just bring it in, it's all good. If you bring your data in from something like the web or Excel or a CSV file, we guess at the best data type. And we don't always guess right. We try hard, we look at the data, but if you've got 1 million rows, we're not going to look at all 1 million rows, we'll look at the first 1,000. And when we can't tell, we'll default to text. So go back, make sure you have the right data types when you bring things in. And yes, the query tool does have a few more data types than the model. That's a problem we want to fix. But those date time types that you see in the query side, they eventually end up basically as a date time in the data model. One thing to be aware of when we're talking about numeric data types, if we bring something in from something like Excel, we will make that thing what we call a decimal. It's the exact same thing that Excel calls it. It's the exact same thing that Excel uses it as. Basically, it's a value that can have a fractional component that can vary. However, if you care about rounding, if rounding is super important to you for budgeting or whatever reason, you may not want a decimal. Those little fractional values can bite you in the end. So you might want to convert some of your data types to fixed decimal. Fixed decimal will round to 4 decimal points. And the whole number, of course, will leave you with 0 decimal points. The fixed decimal is the same as SQL Server's decimal 19.4, or what was called the currency data type in Power Pivot. So the next thing is, when you bring your data in, give a quick look to make sure if it's a geography type, that it's marked as a geography type, for instance. We have a lot of data categories, and a lot of them are around geography. We have a few others around web and image URL, but double check that we pick that up. Again, we'll look at the data. We can't always tell. We do pretty good, but we're not perfect there. You might want to check as well the defaults for things like summarization or sort by another column. If you look in the field list and you don't see the little sigma there, we won't by default use it as in your x-axis or as a value field. So you can change that. You can change how it's summarized by default as well. And set the format. So if you do those things, a lot of stuff will just kind of work for free. the entire reporting canvas is kind of built around the idea of these defaults being right. So, we get complaints like my visual's not displaying correctly, I'm getting weird results, I can't connect up these two fields, what's going on? It didn't detect the relationship. Why is that? Well, one was a text data type and the other was a numeric data type. So just check those things. I kind of put these first couple of things in the category of make sure your car's filled with gas, it's got oil, windshield wiper fluid's filled. That's kind of what this stuff is in that category of. So I want to get that out of the way, though, before we go on to some heavier topics. Just make sure that's right. Put that in your list of things to do first. All right. So let's talk about relationships. What I want to do here is I want to open a file that kind of illustrates some of the concepts where we start talking about relationships. So let's go ahead and open the, yes. This guy. Okay, so I want to get some terms down. And some of you may know these terms, some of you may not. It's useful to know these terms so we're all speaking the same language. Down here at the bottom, I have a project hours table. So over on the left, I've got tickets that were submitted by some person for a project and the number of hours that they worked. Now, when we record information about an event, a thing, something that happened, it's typically something we call, in the BI world, we call that a fact table because we're recording a fact, something that happened. And then up here on the left, I've got two tables. I have a dimension table, or employees table, and I have a dimension table. If you look here, I have employee, I have Bento Nuno, and I have additional information about Nuno. He lives in Redmond. He's been with the company 15 years. So we call these dimension tables. If you're from the database, if you're familiar with the database world, they also call these things lookup tables, right? Because I start here, maybe this is a number, I go to the employee number, and I have a bunch of additional information that's there. All right. So now let's go quickly over here, and let's look at how things are arranged. So I have my project hours table connected up to these two dimension tables, and you'll see that I have a one-to-many relationship. So I'll go back here. Bento Nuno shows up once here, and he shows up here. We have Alan Brewer, who shows up here. He shows up here. He shows up here. He shows up here. One-to-many relationship. Okay? Happens many times in this fact table. So we say that this is a fact table typically is characterized by being on the many side of a relationship. Now, the interesting thing is that almost all of BI is built around this idea that if I have a table that's interesting where I want to sum things up, I can slice it and dice it by these things that are, if you think of a cube, a dimension of projects, a dimension of employees, I can slice it and dice it lots of different ways. And so they're called dimension tables for that reason. And so I can get reports like this very easily, right? I can say, okay, so here's the number of hours for priority projects. And if I just click on here, I see all I did is I put on priority and hours, and boom, it just works. It sliced it by these projects here, A, B, and C, and it got them out of this table. It just did it for free, right? And over here, hours by city. Again, all I did was put over here city and hours, and boom, it works. I can slice and dice. And so that's that concept. So we call these things that are kind of sitting up here dimension tables, and the thing down in the middle a fact table. So let's look briefly then. Let's talk about what we mean by that. So this is the concept we've been talking about. This is the relationship we're looking at. And we call it a star schema. We call these things star schemas. There's a single fact table in the middle, and there is sitting off kind of in finger way. I'm in the middle. I've got my arms pointing out like this. If I was a sea star or something, I can point to these things that are dimension tables that are attributes about me. So I have dimension tables and I have a fact table. The key characteristic of a star schema is that there are no loops. In other words, while there is a connection here between this table and this table, there is not a connection between this table and this table over here. There's no three-party table or more loops. They don't exist. And when you have a star schema, if you have one, life is very beautiful in the BI world. A lot of stuff just works. And so that's kind of the first thing to know, right? Here's another example of a variant of a star schema. This is called a snowflake schema. It's just a star schema with some more things hanging off the ends, right? That's all it is. Again, the key characteristic is there are no loops back, right? There is no relationship between this thing to this thing. I can't travel in a loop, okay? All right. So, let's go back to the product. Because the plot thickens. If life was that simple, it would be beautiful. If people only wanted to ever basically sum things up over here, it'd be great. It'd be beautiful. But they don't. But I want to illustrate one other thing quickly, so you understand this. So when in this report here, I have over here, I have B, and it has 77 hours. How did that happen? So let's walk through that. When I say I want priority, what it does is it looks in that table, this table first, and it says, what are the unique values? And then it's going to, okay, I want B here. And then it says, how do I find B? So it finds all of the records that have B, which have purple and red in them, in terms of projects. And this filters down, it flows down. You see that little arrow? Can't see it very well. It's a little arrow pointing down. Flows down to here, and then it filters all of the projects that only have purple or red, because those are priority B projects. Okay? So that's how it works. So the way to understand this, you're looking at this thing and you go, okay, I have a filter and it can flow down. All right. Okay, so, but then, you're sitting here and you're working with somebody, or maybe you want to find the count of projects by city and employee. Well, that's kind of weird because I was doing all of my aggregates and my sums down here. How are we going to do that? It's not so easy, right? So what we did to make this work is we said, you know what? We're going to let you have that set of records flow both ways. And now if I go back to my report, you'll see it works. Okay? So we call this bidirectional cross-filtering. And the first thing you should know then, if we go back to our deck, is that when you have bidirectional cross-filtering turned on, it's as if it's a single table for query purposes. Because you can query from one, you can put your sum or your count on any one of those things, and the right things will happen to aggregate. Okay? You don't need to flatten your tables. You don't have to do that. This will just work like it's one great big table. So, relationship advice. This is not a marriage counseling thing. Relationship advice number 1. Do not flatten your tables. You don't need to. It's a lot of work to do this. Okay? I was talking to a former Tableau user who said she spent all of her time flattening her tables. You don't need to do that. All right? And quite honestly, you can actually have multiple relationships. Right now I have project hours, but if I had a timetable here, for instance, I could have ticket open date, ticket close date, ticket resolve date, blah, blah, blah date. I have lots of relationships between two tables. Only one can be active at a time because that's the default query path. And that's still a star schema. That's okay. The relationships we don't want are the ones that go between three tables. If it's going between two tables, it's fine. So that's the first thing. Don't flatten your table. Second thing, love the star or snowflake schema. Okay? It makes everything work well. Okay. So I just said don't flatten. There are some cases where you may need to flatten. They're more on the edge case. If you have a really, really large data set, if you're pushing terabytes a day, whatever it is, depending on what you actually are working with, you may want to limit the data set size before it shows up in your data model. That may be a good reason to do it. Or you may want to, for security purposes, do something like that, kind of filter some things out. And in the query tool, there are some anti-joins, which we don't support in the desktop directly, in the modeling tool experience directly. Okay, so you might be interested in how we do this relationship detection. The prime directive, as you might have guessed, is don't create any loops. We can't, right? So that's the prime directive. And we do it in three different times that you might encounter. The first is that you're bringing data in on load or import, or when you add data to an existing data model, we'll look at it and say, hey, where can I add relationships? And this is a very fast look. We do have a slower look. That's the second one. It's a very fast name and data type kind of match is what it tries to do. So that works. The other place that you can do it, it's a more invasive look. It'll actually look at all of the data, and it'll look for what we call high-confidence relationships. That happens if you bring up the manage relationships dialog and say detect relationships. That's what that'll do. That can take hours, though, if you had 50 tables and a couple, 100 relationships. That can take a long time. So this is probably only useful if you've got smaller schemas. And the final one is similar to a feature that we used to have in Power Pivot, which is that we didn't find any relationships. You drag two fields onto a visual. They're still not related. We'll say, I don't see a relationship. Would you like me to go look? Because now we know it might be between this table and this table, and we'll look for anything between those two. So relationship detection in rough order, basically, it sets the cardinality, sets the active, inactive, no loops. It starts by setting directionality to single, and if it can detect that it's a star schema, it'll make everything bidirectional. Okay? Anything else is single directional. So that's where we start. Okay, so we are zipping along here. Okay, so let's talk about that's kind of how we do relationship detection and the bidirectional cross-filtering. So you have that under your belt. Now we can talk a little bit about multiple fact tables. Okay, so this is a schema that somebody sent me not too long ago. So when you have this bidirectional cross-filtering, things get a little different. So if you bring in all of Northwind, for instance, you're going to have a lot of relationships, and we'll set everything normally to single. But you can get yourself into some funny situations. So this person sent, if you start turning on bidirectional cross-filtering without thinking about it deeply. So this relationship right here, the customer complaint was, I'm trying to create a relationship between forecast and my date table, and I can't do it. It says there's already a relationship. What is the problem? There is no other relationship. There's only one. What's your problem? So I took a schema and I got rid of the tables that are not involved in the story, and we're left with this. Anybody see the problem? Yes, it is. Yeah, bidirectional cross-filtering at the bottom. It's a single table. And so really I've got a relationship between this table here and a relationship between this table too, and I can't have two active relationships. Okay? So again, think about your tables that are involved in bidirectional cross-filtering as a single table. So solution is easy. You just turn those things back to single directional. And then we're back in this world where I have two fact tables, the one here on the right, which can slice and dice by well headers or dim date, or forecasts, which can slice by this or this. Either way works, okay? So relationship advice number 2, think about your tables in bidirectional cross-filtering as a single table. And if you have a complex schema, start with everything as single directional. That actually is where we try to start you by default. Again, that's what the relationship detection algorithm is supposed to do. But first get your fact tables working together and then hook up the dimension tables, okay? Layer on the bidirectional after the basics are working. Now, one way to solve the problem is the way that we showed you with the filter direction. There's another way to solve this problem, however. I think I want to open this guy. So if you were an old BI pro, you didn't have bidirectional cross-filtering back in the day. So that's not how they would have solved this problem. Here's another example, similar to the one that we were just looking at. I have two fact tables, fact sales, fact inventory. This could be forecasts. This could be actuals. It could be a lot of things. And I'm slicing and dicing by a common set of things. Now, this works because if we kind of recall the filter direction story, if I want to filter by something here, you see that the little filters can only go this way. They can only go this way. I don't have a problem with something from fact sales being able to go back around this way. I don't have that problem. But if I try to turn on bidirectional cross-filtering here, it let me do one, but it won't let me do both. Okay? Why is that? Because if I started here, I could go down like this, and this would allow me to go up over here, and I could go down like this if this is, and I can get myself into a mess. Okay? So that won't work. But if I really wanted to, and so, there's really a question, if I wanted to count product across stores, there's the question of, do I mean the product for stores for sales, or do I mean the product for sales for inventory? It's not clear. That's what loops are about. It's ambiguity, right? The loops make things ambiguous. If I really wanted to sum across these things, I do have a solution. I'll delete this relationship, and I'll delete this relationship. And then I'll go over here, and I will say, I want to create a new table. And I want inventory product to be equal to dim product. Done. I've just replicated that table. This is what calculated tables do. This is the simplest of all calculated tables, equals. And so I'll go do, so what I'll do is I'll go add the other one as well. Reduce this guy. New table. And I have another table. So now I just come here, let me scroll out a little bit, and I'll put these guys in their rightful place. Oops. And I want store key to store key and oh, look, it's bidirectional. And I want product key to product key, and it's bidirectional as well. And now I can do my sums for both of these across both of those dimension tables, and it all works. Again, love the star. There it is, right? And I might be correlating inventory and sales. I might be correlating them in some measures or something like that, or I might not, right? There doesn't have to be a relationship at this level in order for me to do interesting things with them, okay? Again, if there is a relationship, though, if there was something here that I wanted to say that was interesting about the relationship between two fact tables, what I would do is I would first create that relationship and get that working before I had the dimension tables up there. And then I would get that working, I would layer things on, okay? All right. Let's see. Where are we? Okay. Okay, so you can use calculated tables to reduce ambiguity. And they're just like any other table in your model. You saw me create relationships to them. They get updated when your model is updated. And you will get the right results, okay? The BI world calls these things role-playing dimensions. They do make your model bigger by the size of the dimension tables because I've duplicated them. They're just like calculated columns. So they're just going to end up in the model. And they get you to basically a star schema kind of place, all right? Okay, many-to-many. Another favorite topic among, or pain, for a lot of people. Okay, so there's two kinds of many-to-many problems that we hear about. The first one here is, it has to do with basically the relationships. There is an existing many-to-many table, and oh, it makes my head hurt when I try and get the relationships working. In fact, there was a paper, if you know Marco Russo, he published this, the many-to-many problem, and he published a solution to this thing. And then the other kind of problem is when the table's completely missing altogether. I have two tables, and I want there to be a relationship, and it doesn't exist. Okay, so those are the two sort of many-to-many problems. So let's review this one first. So in this one, I have a fact table, it's a transaction table. And this is recording things like, the amount for a sale. And so, this is a record of sales, maybe the way to think about it. And then over here, so then I have there's accounts associated with this. And I have a customer, but in between customer and account is this table. And this table is a many-to-many table. And it keeps track of the fact that a customer can have lots of accounts.
Your mouse isn't showing up on screen.
Oh, sorry. Sorry. So this is my transaction table. This is showing the accounts. And I've in between customers and account, I basically have this table here, which is a junction table. And it keeps track of the fact that a customer can have more than one account. So what happens? Let me change this thing so I can do it right here and see what I'm doing. Okay, so what happens? So when I try to do a sum, when I try to put, say, Henry Waxman here and get an amount, what happens? Well, Henry Waxman tries to come down here. It gets down to here, but it can't go this way because of this little arrow. And so it can't sum. And so we get the same value for each of these things, right? You can solve this problem with DAX today, right? You would write this lovely bit of DAX. It's complicated, and it only works per measure. And this isn't a DAX class anyway. This is a data modeling class. So, here we go. So this is the solution. You just change the bidirectional cross-filtering on that table, and suddenly now I've got effectively a single table now that I'm going to. which is this customer account, and it works. Okay? So that's one problem in many-to-many. So this is bidirectional cross-filtering was actually designed to actually, customers would come to us with this problem. So we said, how do we solve this? And so it was actually designed to kind of help solve this problem. Okay, so now let's talk about the missing table problem. So now what I want to do, I think I want to open oh, wrong one. Oh, I know what I want to do. I want to start here. Okay. So to review, I have here, this is the data I was looking at earlier, but it was in the desktop. I have project hours, and I have company project, and I have company employees. This table here in the middle, which is a many-to-many table, exists, and it records sort of the legal instances or the legal sort of records that exist as between project and employee on the subject of project hours. That's what it is. It's not every possible combination of Alan Brewer for all of these project types. That's not what this is. This is a reduced subset of the possible set of combinations. But some people want that combination table. They want the cross-join is what it's called, of both of these two dimension tables. So that's what we'll show you here. So I'll go ahead and bring in, do a new instance. And let's go ahead and bring in this guy again. And I'm going to bring in just employee and just project. Okay, so now if I go look at these guys, there they are. And I'll go do a new table. And also I want my cross-join table to be equal to, what do you think the function name is? Probably cross-join, right? Cross-join. And I want employee, comma, project, close paren, boom, there it is. It's a calculated table, which means over here, I can do something like this, and this. It's all connected up. Now, a cross-join table, to be clear, it's the full combination of all possible combinations. It's everything. And it's not always that useful. But if for some reason you knew formulaically, you could maybe add a new calculated column here and say some interesting things. If it's a combination of this and this, it's true, and then you could use that in your, you could use that. But when people ask for many-to-many, sometimes they come to us and they have this table over here and they have this table over and it's missing. And they say you can't do many-to-many. Well, we can do many-to-many. The question is, what do you want to do with it? Right? Okay. So that is many-to-many. And so now let's talk a little about, we've been talking about these. But let's be a little bit more universal at this point. Let's talk about all the things that you can do, or some of the more useful things that you can do with calculated tables. We've already shown you equals, and we've shown you cross-join. But there are a number of others. There's distinct, there's union, there's intersect. These are set kind of oriented things that you can do. Natural inner join, natural left outer join, you can do those. Cross-join you've seen, filtering. Now these right here, summarize columns and summarize, they actually kind of give you a view onto the kinds of things you get back when you're doing a query, for instance. You can use these to debug, for instance. They're quite useful. And the last two, which we will talk about, are calendar and calendar auto, and these allow you to create date tables. So I'm going to do, I think, one demo here. Let's keep going with, so you see I brought in company project here. What I'm going to do, I'm going to come back here. Let's delete this. Actually, let's delete this. I'm already sort of connected to here. I want to bring in, I'm going to bring in project hours and project additional hours. Here we go. And what I would like to do here is do new table and say I want my new table to be the union of project hours and project additional hours. You want to union things together, you can do that, all right? If you want to create a dimension table, I'll do one other quick example because I really want to spend some time on dates. One other example here is states. This is it here. So this is a file where I've got maybe a state with some sales prospects, some state with some deals that are going on, some closed deals. And I want the union, I want all of them, but I want a unique set of these things, right? So I can do that. You can nest these functions together. Because actually when we say union or we say summarize or we say distinct, they're actually functions, and you can just nest them to get what you want. So this is, you can see here I get the distinct set of closed states. I get the distinct set of current deals, etc. I union them all together, and I take the distinct set of that. Okay? So I can do a lot of really crazy things here, all right? I'm not going to take the time right now to go over the you can augment your model, basically, if for instance, you had, in one of these over here, I've got a good example of, well, you can augment your model by creating, actually, dimension tables if you want. If you want to extract the values out, for instance, all A, B, and C, for instance, if that's the code, and you know that A means something and B means something, you just take the distinct values, and then you've got the list, create a calculated column to the right, and you can just put in whatever name you want. You just do a little switch statement. It's very easy. Okay. So, calc table advice. Use calculated tables to understand and also augment your model. All right? Not just to disambiguate, but you can actually augment your model here. And again, they're just like any other table in your model that has relationships. Okay. So now we're going to move to calendar tables, which are a type of calculated table. And I think what I want to do here, I'm going to close these guys. I don't need these guys anymore. All right. So now I'm going to open this. Okay, so I have here a date table. Okay, what I did is I brought in my sales table and I created a date table. Now the date table is not connected to sales in any way. I've not hooked it up. If you look over here, if I do something like this, if I say something like here's sales amount, I want a little visual and I want invoice date, for instance, I get date functionality going on here, but this is not this. Okay? There's actually a private date table, which I'm going to show you in a minute, behind the scenes that we put in automatically, which you can override. But I want to show you first how I create, or how you could create one of these date tables. It's very simple. So I mentioned there are two calculated tables that are related to dates. One is calendar, the other is calendar auto. This one is built using calendar auto. The first argument is the fiscal period that you want the calendar table to end at. By default, it is 12, so it's December. You can change it to 6, and you have a fiscal year. Okay? And what this function does, is it looks at your model. It looks at every single date field in your model, and it finds the earliest of all of them and the latest of all of them, and it pads it out to the beginning and the end of those years, and fiscal year if it's a fiscal year. So for instance, if you had dates that started in February, but your fiscal year went from January through December, it would pad out the dates in this table to be January 1st. And if the last date was in October, for instance, it would pad it out to the end of the fiscal year, whatever it might be. So you would have, this date field would have all of those dates. So I'm going to leave this as 0, which is what it is anyway. Whoops, what did I do? There we go. The next thing is you just put in this function here, year of this date, month number of this date, month name, which is a format string of this thing here, and then I choose to sort it by this. And I have a date table. That's it. That's all you have to do. Okay? All right. So now I'm going to start. I'm going to actually close. That's from my previous demo. I want to close all of these guys. Anything left open? Go away. No? Okay. I'm going to run this special little command. We'll let you see into the bowels of the product. Okay, so I've just started up this product, and there's nothing in here yet, all right? And you can see that there's already a hidden table here. It's a template table is basically what it is. And we use that. It's got one row in it. We use that to create the template table with the tables for each of the files that we bring in. Now that here, I can open this guy, and you can see what's going on. So this is the table that we had open a few minutes ago. And if we go to the relationship view, and I move this because for some reason it likes to sit on top of that thing. This is not a view you normally see as a user, but I want you to understand what's going on. The fact that this thing has a date table is a bug. This shouldn't have a table. But here's my template table, and here's the other table that I'd created. And this sales table has 2 date fields in it. It has invoice date and order date. And for each of these, they get their own little private date table, which you don't see. So when you go to create this guy here, and you say sales amount, if I get my glasses going here, and I say invoice date, order date will do. And this shows up. This shows up because of this. Okay? If I don't want that, it's easy. Which one was it? Order date? Whatever it was. It's gone. Anything I put into the model that I create and I connect up, the private date table will go away. It's gone. Now the interaction is traditionally the way it's always been, which is that I just go to the field, just pick things off of the date table that's been published, and I just use it. If I say, oh, no, just kidding, I don't want that, the date table, the private little date table comes back, okay? And it's there. You can turn this off or on. Actually, it's on by default. Here. Okay? So you can turn that auto stuff on or off. It's up to you. All right. Back to the slides. So, and if you should, my understanding is you get a copy of the slide deck. So if you, these are online if you want them. But if you want to calculate your own date tables, these are the kinds of formulas that you would do. They're very straightforward, very easy to do. In the little date table that I created, I did month number, year, and month, right? But this is how you do 554 calendars and all that other kind of stuff. Now, we are halfway through our implementation of the built-in date time functionality. And you see that by virtue of the fact that when you create an invoice date, you get some things. You can go back to the original date there, by the way. You just click on the little pill. You can go to the original date. Maybe I should show people that so they understand that. If for some reason, this shows what happened when I deleted it. But basically, order date, I can choose to use order date or the hierarchy. If I use the hierarchy, I get this. If I don't want that, I can go back to this. So it goes back to the original field. But going back here, you can create your own date tables. It's not that hard. But there will be basically a place to edit the template date table that we've been showing you. And you'll be able to enter in crazy company holidays, whatever you want to do, and they'll just percolate to all of those those private date tables. So, final piece of advice. Oops, no, that's not it. There will be a programmatic way to refer to the private date tables with a dot notation. You'll be able to say something like sales order dot date, etc. Be able to use them in any place you wouldn't use a normal calendar date field. So that's all coming. And the DAX queries will return dot notation names, etc. IntelliSense is all going to work with it. And you can use the private, I previously said, if you've heard me before, don't use the private date table names. You can use them. There are cases where it's important. All right, final piece of advice. Use both, work with the built-in stuff. There's going to be a lot of really wonderful functionality there. It's going to really make it easy to work with dates. But again, you can always override it. You will always need to customize for crazy calendars that you need, but the template date table will allow you to do that. And it'll be through the kind of thing that we showed you, although we may have some quick calcs that may accelerate some of those things. It'll be a couple more months before the full built-in date time functionality is really there. All right, so hopefully today you've learned a couple of rules, guidelines. Data modeling is, I know, the most exciting subject you could be talking about. But hopefully, if you follow these rules, you'll be in a good place. You'll be in a great place for the rest of your model. There's all kinds of crazy things you could do if you're a BI pro, where you want to get into really big schemas. But this should help you if you're dealing with moderate schemas and should put you on the right path. Thank you.